In this exercise, we will ask what happens to an initial state as we evolve it over time according to the Markov dynamics. Now we'll assume that we start in an initial state at time 1 where S1 is equal to -1. That is, we concentrate all of the probability over S1 in the state minus here. The purple line is full height. And there's 0 probability in the plus state. So the probability vector here would be 1, 0. Now we evolve forward over time. And so some of those minus states transition into plus states, and some of the minus states stay as minus states. From there, we evolve further over time, and some of those minus states that stayed will now switch. Some of the plus states that had switched will switch back, and we keep evolving over time, mixing these two states until after a long period of time, we will approach an equilibrium where for these dynamics, you'll end up with a 50-50 mix of plus and minus states. Now, these transition dynamics you've seen before. In the previous exercise, we used them to sample the next state from a previous state. Here, S equals -1, you would sample from this distribution for S2. But now we're going to retain the entire probability distribution because we're trying to predict the future. And that means that when we go to the next state afterwards, trying to predict S3, we have to compute the average transitions averaged over the probability of S2. So S1 again switched from minus to plus for some of them, and some of them stayed. And the plus, likewise, the plus states at S2, some of them switched back to minus and some of them stayed plus. And we can average those two transition probabilities weighted by the probability of S2. We're propagating forward in time this probability distribution over the states given S1. Now mathematically, we start with a delta function on S1, that is, all of the probability mass is concentrated on S1 equals -1. And then S2, once we're given that information, is just the one-step prediction, and that's the transition probability that we've already seen. S3, on the other hand, now we have to sum over all of the possible ways that S2 could have arisen. So these are really averaging over all trajectories that you could have taken from S1 to the possible S3s. So this is a two-step prediction. And we can keep going. S4 given S1 is a sum over all the intervening states. How did you go from S1 to S2 to S3 to wind up at any particular S4? So that is a three-step prediction. Now, this exercise is an interactive exercise. We've already coded everything for you, and you're starting from state S1 equals -1, and your job is to interpret and understand. So the first thing is that you should take a look in the code to see how we calculate the predictive probabilities for those future times when we don't have any measurements. And then we have code for you to visualize or plot how those probabilities evolve over time. So take a look at those plots and manipulate the switching probability from different values of 0.05 or 0.2 or 0.5 or even 0.95 and explain your observations in each of those cases.